Now that we've been performing transformations of functions for a while, let's go back and let's summarize some of the things that we've learned here, because the idea is we want to be able to perform these, but we also want to explain how and why they work the way they do. So remember, the big idea when we're dealing with functions is functions make shapes when we graph them. Functions make shapes when we graph them, and the transformations change those shapes. Transformation change those shapes. Now here's the summary of what we've learned so far. And as we come across an asterisk, that's going to mean that we're going to do the opposite, because we learned that that happens sometimes. You'd think it would go one way or it does one thing and it actually does another. So if we see an asterisk, that means that we're going to do the opposite of whatever we would normally expect. So we've got a vertical shift right here, no asterisk on this one, and you'll notice the form for this is y equals f of x. So whatever the function shape was, it made this shape. And then after it made this shape, we either add or subtract k. So if it's plus k, we're going to add k to the y value. And if it's minus k, we're going to subtract k from the y value. So each one of those y coordinates, we're either going to add or subtract something to it. So on this one right here, this is a horizontal shift. So notice the asterisk right here. And notice that there's a different structure here. We have the x and then we either add or subtract h, and that's inside with the x, inside with the parentheses there, before we plug it into the function so that it can make the shape. So you'll notice that first comes a plus, but we subtract h from the x coordinate, and if it's a minus h, then we would actually add h to the x coordinate. And then we'll take a look at a vertical stretch, shrink, or flip. So that's where we have the regular old function right here. So here's f of x right there. And then we're going to have an a multiplied by that outside. So we're going to multiply the y coordinates by a, and that's going to vertically stretch it or shrink it. And notice that if this happens to be negative, that's what's going to flip it upside down across the x-axis. That's going to change the sign of each one of those y coordinates. And then we've got a horizontal flip. That's when we take the x, we multiply it by a negative before we let the function make the shape. So multiply the x coordinates by a -1. And then the last one is a horizontal stretch or shrink, and you'll notice this also has an asterisk. So again, we're changing the function before it makes the shape. We're changing the x, then we're plugging it into the function to make the shape. So we're going to multiply the x coordinates again, but we're going to multiply them by the reciprocal of b. Now you could think of it as dividing by b if you wanted to. Better in the long run to think of it as the reciprocal of b. So here's what we're going to do. We're just going to practice this a little bit on two different examples. Same function, but two different examples. So here's the original graph of f, and here's a table for f. So we've got each one of these blue dots right here corresponds to a point on the table. So here's what we want to do. We want to complete these tables, we want to sketch the resulting graphs, and we want to describe the transformation. And a little bit of a hint, it may be easier to describe the transformation first and then graph it, then fill out the table. It's really up to you. It's just a personal preference. So I'm going to take a look at this one right here, and on this one, we're going to describe this first. We're going to figure out what goes on here. Well, this is f of x plus 2. And then minus 3. So we're changing the x before the function even gets a chance to make that blue shape up above here. So this is going to actually move these to the left. So I'm just going to write left 2. And the minus 3, you'll notice that this is outside. So once we've changed the x, plugged it in, made that shape up there, then we're going to take this and we're going to move them down 3. So I'm going to do down 3. So let's just take these, and what that means is we're going to take each x coordinate and move it to the left. So that means we're going to do minus 2 from each x. And if we move it down 3, we're going to subtract 3 from each y. So let's just take each x and let's subtract 2 from it. So if I subtract 2 from -4, we get -6. If I subtract 2 from -1, we get -3. If we subtract 2 from 1, we get -1, subtract 2, we get 1, and subtract 2, we get 2. And then we're going to take each one of the y coordinates and we're going to subtract 3. So if I subtract 3 from this, I end up with 0. Subtract 3 from this, I get -3. Subtract 3 here, we get -1. Subtract 3 from here, we get -1. And the last one, the y coordinate is -1. We're going to subtract 3, so we end up with -4. Now let's go ahead and sketch these and then see what it looks like. So we should have a point at -6, 0. So we'll be right there. -3, -3. So -3, -3 would be right there. -1, -1. So right there. And then 1, -1 right there. and then 2, negative 4. So over 2 and down 4, so we'd be right there. So let's go ahead and connect this, and I'll give you a little hint. That doesn't look very good. If we draw these as straight as we possibly can, and connect those dots. Now we'll compare it with up above. You'll notice that we haven't changed the shape at all. So this blue graph up here looks like this. The red graph down here has basically been, you can kind of tell it's been moved over and down. We haven't flipped it upside down, we haven't stretched it, shrunk it, or anything like that. So we're in good shape there. Now I do just want to check and make sure that we understand how to do it both ways. If you wanted to think about this and just up here on this blue graph, you wanted to say, hey, I'm going to take this to the left 2, and then I'm going to go down 3, left 2, down 3, and do each one of those, and then come up with the coordinates, that would be fine. It would be really good if you could do it both ways. So on this one, I'm going to make the changes up here, and then we'll figure out what the points would be on the table. So let's describe what goes on here. So on this one, let's see what we've got. This is multiplied by a negative 2. So this is going to be a vertical flip. So I'm going to do vertical flip. And it's also going to stretch it by a factor of 2. So stretch by factor 2. So it's going to get multiplied by 2. That minus 4 right here, that's going to move it to the right 4, because remember, it does the opposite of what you'd think. You'd think it would move it in the x direction, negative 4, but it doesn't. It moves it to the right. And then this one right here is going to move it up 6. So we're going to go right 4, up 6, and that's after we've changed this shape by vertically flipping it and stretching it by a factor of 2. Okay, so let's come up here and let's see what this would look like if we did that. Now I'm going to change colors. Let's see. So we're going to take this and we're going to vertically flip it and stretch it by a factor of 2. So if I vertically stretch it, it was 3, so this is 3 above the x-axis. I'm going to vertically stretch it by 2, multiplying by 2, so that's going to be 6, and then I have to flip it upside down. Another way to think of it would be we could flip it upside down to negative 3 and then double it, so we'd be right here. Let's see, this one, if we're vertically stretching this, this is 0, so anything times 0 would be 0, so we're going to stay right there. This one we'd, again, flip this upside down, so that would be negative 2 for a y coordinate, and then we're going to double that, so that would be negative 4. Same thing on this one, flip it upside down and then double it, that would be negative 4. And then flip this upside down, so that's going to be above the x-axis, and then double it, we're going to be right here. So I'm going to do a dotted little graph right here. Let's just take a look at it. Does that look like it's been vertically flipped, so flipped across the x-axis, and then stretched by a factor of 2? That graph definitely looks steeper and taller than it used to be. Then we're going to take these and we're going to move them to the right 4, and then we're going to do up 6. And I'm going to do this in red. So we're going to go to the right 4 and up 6. So we're at negative 6 right now, so that's going to put us right here. And then we're going to go to the right 4 on this one, so to the right 4 and then up 6. So that's going to put us up here at positive 6. We're going to take this one, this one right here, we're going to go to the right 4, so that's going to put us here. And then up 6, so up 6 would put us right there. And then right 4 and up 6 would put us right here. And right 4 and up 6 would put us right here. So I'm going to go ahead and do a dotted graph for this one, and let's just look at it and make sure that this looks right. It's the same shape as we had before, we just moved it over and up. So I'm going to just transfer those points over here. I'm going to go backwards, so I'm going to hit this one, then this one, that would be 7, 2. So we're going to be right here, and then that's 5, 2 right there. And then this one is 3, 6, so over 3 and up 6, we're right there. And then that one is 0, 0, okay? So let's see what we've got here. We'll try and connect those really nicely. Get that all connected, and that's what it looks like. Now, does that look like the blue graph that's up here is the parent function? Does that look like we vertically flipped it, vertically stretched it, and then moved it to the right and up? So right 4 and up 6. That looks pretty good to me. Now what I'm going to do is I'm just going to write down what would happen here. So the first thing we're going to do is we're going to start from the inside. So again, minus 4, you would think that that would subtract 4 from each one of the x coordinates, but we actually do the opposite. So we're going to do plus 4 to each x. And then we're going to make this shape right here. So we're going to do negative 2 times each y. And then the last thing here is we're going to take each one of the y's, because remember this is outside the parentheses, so that's going to change the y. We're going to add 6. So plus 6 to each y. Now, the only change we need to make with the x's is we just need to add 4 to them. So I'm going to come up here and say if we add 4 to negative 4, we get 0. So we'll mark a 0 down here. If we add 4 to this, we end up with 3. If we add 4 to 1, we end up with 5. If we add 4 to 3, we end up with 7. And if we add 4 to 4, we end up with 8. And then, let's see, we need to multiply each y by negative 2. So if I multiply by negative 2, we're going to get negative 6. We're going to get 0 right there. That would be negative 4, and this would be negative 4 because we're just multiplying by negative 2. And then this is going to turn into a positive 2. And then we want to take each one of those y's and we want to add 6 to them. So we're going to add 6, add 6, add 6, add 6, add 6. So we end up with, this would be 0. This would be 6. This is going to be 2. That's also going to be 2. And then this last one is 2 plus 6, so we end up with 8. Now let's just check and make sure that we've got this right. Well, 8 comma 8 is right there. That one checks out. 7 comma 2, right there. That checks out. 5 comma 2, that checks out. 3 over, 6 up. Yep, that one checks out. And then 0, 0. Looks pretty good. So that's how you do it. Again, putting all these pieces together, you've got a really good sense of how transformations of functions work at this point. So have this kind of memorized, lock this away with all the practice that you've been doing, and just realize we don't spend a whole lot of time doing horizontal stretches, shrinks, or flips in this class, but you will use them in other classes, but at least you've seen them at this point. All right, good luck on the assignment.